We are going to be looking at graphing quadratic functions using the vertex form. The vertex form is f of x equals a times the quantity x minus h squared plus k. In this particular form, the vertex is going to be the ordered pair hk. Let's begin by reviewing graphing of lines. You're familiar with graphing lines by plotting points. We can consider the example of the function f of x equals 2x minus 3. This is a linear function, and therefore the graph of this will be a line. One way to do this is to find at least 2 points on the line. We can do this by making a chart of values. I have a small little chart here, and in this chart we are going to come up with 3 different ordered pairs that are on this line. We can choose any value we want for x, and I have chosen -1. We have a fire drill going on in the background. I don't know if you can hear that or not, but this is the way life is at Chattanooga State. Anyway, if we take -1 and substitute it in for the x value, we're going to have 2 times -1, which is -2, minus 3 gives us -5. Another value we could choose is x equal to 0. If x is equal to 0, we have 2 times 0, which is 0, minus 3, which will give us -3. We don't have to find a third point, but it is often advisable to find a third point. I will choose the value x equal to 2. If we substitute 2 in for the x value, we will have 2 times 2 is 4. 4 minus 3 will give us 1. This gives us 3 different ordered pairs. Now, this particular graph, we have all 3 of these ordered pairs. Here's the ordered pair 2, 1. This is the ordered pair 0, -3. And down here we have the ordered pair -1, -5. Connecting these points with a line, we are finished graphing this line. But there's another method that we can use to graph lines, and this is using the slope and the y-intercept. We can start with a point at the y-intercept, and if the equation of the line is in the slope-intercept form, this is very nice to use. In the example that we had before, we had f of x equals 2x minus 3. And so we are going to start at the y-intercept, and then using the slope of 2, we can move to the right 1 and up 2, and we'll repeat this process as needed. You could also move to the left 1 and then down 2. This is how it works. Looking at our point, and we're still using the equation f of x equals 2x minus 3. So our y-intercept is the point 0, -3. So we can see that point down here. Now, what we can do then is move to the right 1 and up 2, giving us a second point. We can repeat this process. From this point, we can again move to the right 1 and up 2. This gives us a third point. Once again, we can see we get the graph of this line. The method that we are going to be using for graphing quadratics is similar to what we just did with graphing lines using the slope and the y-intercept. We are going to be using the vertex form f of x equals a times the quantity x minus h squared plus k. We're going to start by plotting the point at hk, and then we're going to move over and up or down the right amount. The right amount is going to be determined by how far over we move and by the a number in this form for the vertex. Let us consider the example f of x equals x minus 3, the quantity squared, minus 2. For this particular function, f of x equals x minus 3 squared minus 2, the vertex is going to be at the point 3, -2. Therefore, we start by plotting our point at 3, -2. This is the vertex. Now, in this particular function, the a number is 1. Therefore, if we move over 1, we're going to move up 1 squared, This gives us a second point on the parabola. We could also move to the left 1, but then we also move up 1 again. This gives us 2 more points on the parabola or the quadratic equation, quadratic function. If we move over 2, we're going to have to move up 2 squared or 4. So moving over 2, we're going to go up 2 squared or 4. We could move to the left 2 and again move up 2 squared, in other words 4. This gives us 2 more points. We could repeat this pattern, and you're going to move over C from the vertex and up C squared. Here we see the graph of the parabola that we would like to have. Let's consider another example. In this particular example, the A number is 2. This is going to change the steepness of the curve by a factor of 2. If we look at this function, we see that the vertex is going to be at the opposite of 1, or negative 1, minus 4. So we start out with our vertex here at the point negative 1, negative 4. This time, if we move over 1, we're going to go up 2. We can also go to the left 1 and up 2, giving us 2 more points on the parabola. Let's find 2 more points. If we move over 2, we're going to go up 2 times 2 squared. This first 2 is the A. This, I messed up here. My mouse is not where I want it. So this 2 here is the 2 from the A. This 2 is the 2 that we're moving over, and then that has to be the squared. So 2 times 2 squared is 8, so we're going to move over 2 and up a total of 8. Now notice that when I went up 8, I went from here 1, 2, 3, 4, 5, 6, 7, 8. We could also move to the left 2 and again up 8. This gives us 2 more points, and this gives us the parabola. Let's look at another example. In this example, the A is negative 1/2. Since the A is negative, this one is going to be moving down. So this opens downward. On this one, the vertex is going to be at 2, 4. So we started out with our vertex point at 2, 4. In this case, if we move over 1, we're going to go down 1/2 because of the negative 1/2. So we move over 1, down 1/2. We could move to the left 1, down 1/2. This gives us 2 more points. If we move over 2, we're going to go down 1/2 times 2 squared. The 1/2 down 1/2 is from the negative 1/2, the A number, and the 2 squared is what we're moving over, and because it's a quadratic, we move down 2 squared. Computing this, we see that we get 2 down, so if we move over 2, we go down 2, to the left 2, down 2. 2 more points. Let's find a third pair of points. If we move over 3, we're going to move down 1/2 times 3 squared, or 9/2. For graphing purposes, 4.5 is maybe easier to see. So if we move over 3, we're going to move down 4.5. If we went to the left 3, we would likewise still go down 2.5. This gives us 2 more points on the parabola. This completes this graph of the parabola. Let's summarize what we have just done. The vertex form for a quadratic function or a parabola is f of x equals a times the quantity x minus h squared plus k. The vertex is going to be the ordered pair hk. We're going to start by plotting the vertex. Then we move over 1 and then up or down the A number. If A is positive, we go up. If A is negative, we go down. We're going to move over 2 and go up or down A times 4. The 4 is because of 2 squared. If we move over 3, we're going to go up or down A times 9. 9 is the 3 squared. We can continue until you have enough points to sketch the graph. This completes our discussion of graphing quadratic functions in the vertex form.